So till now we understood the concept and wrote the functions for writing the data to a specific location in our SPI based EEPROM and reading the data from the same. Okay, so we have written the functions, that is EEPROM underscore write and EEPROM underscore read for writing and reading the data. Okay, but still there is one essential component missing in our drivers. So for that you need to open your data sheet for the EEPROM, and inside that on page number 11 you will see that a write status register. So if you read the description, they have written that the write status register instruction allows the user to write to the non-volatile bits of the status register. And what does that mean? So they have mentioned that the user is able to select one of the four levels of protection for the array by writing to the appropriate bits in the status register. So it is for basically array protection. Now if you look at this table, then they have mentioned that if you provide 00 into this WRSR, that is write status register, then no area of the EEPROM will be write protected. If you send 01 into this register, then the upper 1/4 portion of the EEPROM, that is from the location 0600 to 07FF, that much portion, that is the upper 1/4 portion, will be write protected. And if you provide 10, then the upper half portion will be write protected. And if you provide 11, then the whole EEPROM will be write protected. Okay, so basically before transmitting any kind of data to our EEPROM, this register needs to be configured. That is, either of these four combination has to be configured into this register. And to write the data, they have provided the timing sequence here also. So first of all, you will have to put your chip select line as low, okay, in order to transmit the data. Then you will have to transmit your instruction, that is 0x01, which is the instruction for WRSR. So that is provided into this SPI.h. So you can see EEPROM underscore WRSR equals, that is 0x01. Okay, so first of all you will transmit the instruction, and then you will transmit the data to the status register. Now what data? Now the combination of these two bits. Okay, so this data needs to be transmitted after the instruction, right? So let us make appropriate function for this. So just open your Eclipse IDE, and inside that just copy this whole EEPROM underscore write function, because the function that we are going to make is similar to this. So just copy it and paste it over here. Okay, and rename this function to EEPROM underscore uh, status underscore reg, that is register. Okay, and the argument it will take will be only one, that will be that will also be of 8-bit. Okay, 1 byte, that is. And what the argument will be, that is the combination, the data that needs to be put into the status register. So I will give it the name status underscore reg. Okay, so now what needs to be done is, almost everything is already done, that is the status checking mechanism is established. Then the write enable bit variable is also defined, and the transmit buffer here, we need to use the transmit buffer of 3 elements. Okay, then first of all we will transmit the write enable instruction in order to enable the transmission. So first of all the write enable will be transmitted, and in the TX buffer, that is the transmit buffer, the first instruction that will go will be of WRSR. Okay, and after that in the first element you need to transmit. So we will remove this, and in the first element what we need to transmit, we need to put this status register. Okay, so whatever we will pass in the argument, that will be reflected over here, right? So this much data needs to be transmitted. Okay, So first we will disable our that is make our chip select line low, and we will transmit our write enable instruction. And if that instruction is transmitted successfully, then we will we will have to actually save our status into this variable. And if the variable is all okay, then the chip select pin will be high. Okay, that means the transmission is completed. Okay, so our write enable instruction is transmitted. Now we want to transmit the transmit buffer. Okay, so again the chip select is made low, and the transmit buffer here, it is of 2 bytes basically. Okay, and we are transmitting it, and again if the status is okay, we will store our status into this variable. And if the status is okay, that is all okay, then make the chip select line as high, and return a return type will be all okay, that is here. Okay, so this whole function is basically completed, right? So we will use this status register function before transmitting data. Okay,